Inside of SOLIDWORKS, I've already created a file for this module. It's M05 cut start. I've pre-sized the outside diameter of this model so that it has the correct diameter for the thread that we'll be building. So let's see how to do that. Leaving under the Hole Wizard button is the threading tool. The first selection is a cylindrical edge of your model where the thread will be applied, and I would normally not skip over the dialogues, but in this case I do like to pick up the size of thread that's needed because it gives a nice preview and you can get a better sense of what's going to fit. So scrolling back up to the top, let's see what we have here. We can define the threads with the number of revolutions. In this case 10 is too many, so let's try 5. And that looks a lot better. Inch die is what we want because we're making an external thread. The selection for an inch tap would be for internal threads. We'll be cutting this thread, and if you look closely at the profile right now, the thread is cutting on the wrong side of this model for some reason. So we have an option to mirror that. That looks a lot better. Right-handed thread versus left-handed thread. We talked about that previously. And let's see what this does for us. Looking at the profile, it's really not that bad. One limitation of building threads with the thread feature is that the starting point and ending point are always abrupt. These are just swept profiles that end up stopping and starting. In the next module, we're going to see how to fix these. So for right now, I'm just going to leave these with blunt edges. For now, let's save this model as it is. And let's see another way that we can create threads using the new thread feature. So let's open up M05 Extrude Start. In this case, I've sized the outside diameter of this part to be a little bit smaller than the previous blue model, and this is going to allow us to add threads to the outside of it instead of cutting threads in. So under Insert, Features, Thread, again, I'll select a cylindrical edge to add my thread to, and in this case, let's take a look at what the offset command does. It allows us to start the thread a little bit below the top edge, which is nice. The start rotation allows you to type in a starting angle for the thread. I'd normally leave this set to 0 or some multiple of 90 so that it lines up with a reference plane, but you could certainly change that if you needed to time the threads for some reason. The end condition can be set with revolutions, which I typically work with, or you can also go with blind, where you'll set in an actual distance for the thread to extrude to, or you can use up to selection. Maybe you want it to go all the way up to a model face. Let's take a look at a quick rule of thumb that might come in handy for you, and just jump into PowerPoint for a moment. When working with external threads, the rule of thumb is to keep them at least 1.5 threads away from a shoulder or flange of some type. And with internal threads, you want to maintain a distance of about 2.5 rotations or 2.5 threads away from the bottom of the hole or some other feature. These clearances are designed for manufacturing needs so that the tools that are being used to cut the threads can actually fit in where they need to go. In order to easily convert between revolutions and distance, you just need to keep in mind that pitch equals lead. And we've already defined the pitch as 1 divided by the threads per inch. If you're working with a metric thread, then the pitch is already given to you automatically. Lead is the distance that the thread will back out of a part in 1 revolution. And revolutions can be easily determined by dividing the distance by the lead. Let's jump back into SOLIDWORKS and see if we can put some of these definitions to use. If we set this as 6 revolutions perhaps, that comes really close to this flange. So we might want to back that off a little bit using the rules that we just learned about and set it to maybe 4.5. Now if we go in and turn on an offset, it'll bump that thread down a little bit and move it even closer to the flange. But SOLIDWORKS does allow this maintain thread length, which will automatically adjust for the offset taken at the front to be taken off of the rear end of the thread as well. One other feature I'd like to demonstrate just while we're in here is the ability to modify the diameter and the pitch of the thread. You wouldn't normally do this for something that's already been predefined, but if we take a look at, say, 1/2 inch threads, we see that they jump directly from 1/2 up into 5/8. This means that a whole series of 9/16 inch threads are completely ignored. So if for some reason you were building, say, a bicycle pedal and needed a 9/16 thread, it would be easy enough just to go in and define that manually. And in this case, it would be a 1 divided by 20. That would give you the thread that you needed, but we're not going to do that right now because this is the thread that we do need. So let's see how this looks. Sorry about that. I forgot to mirror this profile again. Take that back. I forgot to extrude the thread instead of cut the thread. And that's it. Again, we have a 3.5/12 thread on the outside of this part. The ends are a bit abrupt, and like I said, in the next module, we will see how to fix those. Overall, the SOLIDWORKS 2016 thread tool is easy to use, and actually it's what I use to create most of the renderings inside of the PowerPoint presentation, because it's a lot easier to create threads with this tool than it is to do so manually. The main drawback, as we discussed, is that the threads themselves are not accurate. So let's save this model and see how we can build threads manually.